calculations from the equations. So we are doing chemistry, which is more concepts on the calculations from equations. So the first part is more to more calculations, which means if the number of more is given in the question, then the question will require or demands you to find the number of moles from the equations given. So now I have a first example, which is question number 1, which is saying how many moles of chlorine are required to react 2.5 moles of calcium to produce calcium chloride. So the question is simply saying that how many moles of what of chlorine. So for me to solve, first I need to come up with a balanced chemical equation. So now that's saying that how many moles of chlorine are required to react 2.5 moles of calcium. So it means chlorine react with calcium. So I'll write the equation here by saying a chlorine gas, which is 2. Remember, all group 7 elements are the atomic molecule. So it means when you write the chemical formula for chlorine, we put a 2 here, then plus calcium metal, then I'll get what we call a calcium chloride like this. Yeah. So I know that the valence for calcium is 2, the valence for chlorine is 1. So I've swapped the valences. So make sure that when you write the chemical formula, don't forget to swap the valences. Then from here now, I'll try to balance the equation. So how many calcium are here? We have 1. 1 calcium, and calcium here 1. Chlorine here 2. Chlorine here 2 atoms. So which means the equation is already balanced. So now the question is saying that how many moles of chlorine? So it means I'm finding for chlorine, which is this one. So I'll write chlorine here. Then now I'll compare with the one whose now number of moles is given. So that's saying that react 2.5 moles of calcium to produce calcium chloride. So it means this 2.5 is the number of moles for calcium. So this calcium, I'll write the calcium here like this. Then from here now, I know that the numbers in front here, they present the number of moles. Since there's no number here, which means there's 1 here, and also there's 1 here. And then from here, I'll say, okay, the number of moles for chlorine from the balanced equation is 1. Then for calcium again is 1. Then now we'll go to the question. How many moles of chlorine? So chlorine, which means I'll put X here, then I'll put here. Then for calcium, the number of moles given in the question is 2.5. 2.5, yeah, like this. So don't forget that the first stage, you get the compound or element that you are finding or requested, which is the chlorine. The number 2, you get the compound or element whose number of moles is given. So in this case, since we're finding the number of moles of chlorine gas, so we have to write chlorine here. Then number 2, since the number of moles of calcium is given, so we write calcium here. Then from there, we compare the one that we're finding and the one that whose number of moles is given in the question. So from here now we get the number of moles from the balanced equation, which is we have 1 here and the 1 here. So these numbers in front, they present the number of moles. Then we write 1 and 1 here. Then for chlorine, since we're finding for chlorine, we put X. For calcium, the number of moles given is 2.5. Then from here now, you cross multiply, you multiply. So you say 1 times X, it will be X, then is equal to, then 1 times 2.5, it will be 2.5 moles. So this is a moles of what? Moles of chlorine gas. That will be the final answer for this question. Then number 2, again I'll go to number 2, question 2, which is a similar question. So they're saying that how many moles of carbon dioxide? So I'm finding the number of moles for carbon dioxide. So it means I have to do what? I have to write the formula for carbon dioxide here. So what is the carbon dioxide is here? So remember there's a 6 here. So I'll write a 6 and the carbon dioxide like this, okay? Because the question demands me to find how many moles of carbon dioxide will be produced by complete combustion of 2 moles of glucose. So which means the number of moles given is for glucose, 2 moles of glucose. So the formula for glucose is this one. So I'll get it just like the way it is in the equation. So write 6C6H12O6 like this. Then from here now, I'll try to check, since the equation is already balanced, as you can see, we have numbers here, 6, 6, and 6 there. So it's already balanced. So I know that since here there's no number, which means the number of moles is 1. And the question demanded me to find the number of moles. So here, number of moles for carbon dioxide 6 from the equation. Here it's 1. Then now I'm finding the number of moles of carbon dioxide. So which means I'll put X while there's carbon dioxide here. And the number of moles for glucose produced here. In the question they say that is 2 more. So I'll put 2 moles here like this. Then I'll cross multiply. So 1 times X, I'll say it's X. Then 6 times 2, so X is equal to what? 12 moles of glucose. So this is the answer that they wanted us to find. That was the more to more. So for example, like if the number of moles is given and you want to find the number of moles, you can use what to call more to more. So now the next part here now, what we have is the more to mass calculation. So which means we'll be required to find the number of moles or the mass. Then the number of moles will be given. So it's either will be required to find the number of moles, then the mass will be given the question, or will be required to find the mass and the number of moles will be given the question, and vice versa. So now we need to be very careful on this one. Remember the first one, the question demanded us to find the number of moles, and the number of moles in the question was given. So we can use more to more. Now here we have more to mass. So you need to pay attention here. So the first question is saying, what mass, which means here we're looking for mass, which means we write mass here. This side you write mass, because we're finding mass there. We're finding mass here, okay? What mass of hydrogen can be, so what mass of what? Of hydrogen. So we need to check for hydrogen here. So this hydrogen here, as you can see. So write this hydrogen here, with just like the way it is from the equation, like this, okay? Like that. Then I'll put this on top. So what mass of hydrogen can be produced by reacting 6 moles? So which means this side, the mole is given. So I'll write moles here, because the moles is given. So I'll write moles there. Okay. Then from here now, I'll say reacting what? 6 moles of what? 6 moles of aluminium. So which means the number of moles for aluminium is given. So which means I'll write aluminium here, but I need to be careful since there's a 2 here. So I'll write 2 aluminium like this. Okay, which means I'm comparing now mass to mole. Okay, then hydrogen and aluminium. So now what I'll do here, so which means this side I need to write masses. So now how to find the mass? So the mass is same as Mr. So which means I need to find the Mr. for this hydrogen gas. So I'll find it from this end. So I have 3 hydrogen here. Then so what I need to do, I need to write like this. I say hydrogen here we have 2, then times these 3, then times the mass number of hydrogen on the periodic table on top of hydrogen, which is what? Which is 1, which is what? Which is 6. So which means the mass number, the Mr. for hydrogen is 6. So I'll write 6 here like this, which is the mass. Then the moles means the number of moles. So the number of moles from the balanced equation. So I said this number here represents number of moles. So which is 2. So I'll write 2 here like this. Okay. So this 6 is the Mr., which is the mass, because this side I'm putting mass. Then this side I'm putting number of moles, and this 2 in front it presents the number of moles. So this side is for mass, this side is for the number of moles. Okay. So now I'm looking for mass, which means for hydrogen. So which means I put X here. Then the mass, the number of moles for aluminium given in the question is 6 moles, so it means I'll put 6 moles here like this. Then from here, cross multiply. So x times 2, it will be 2x, which is equal to 6 times 6 to be 36 like this. Then over 2 and over 2 here. Okay, then I'll cancel this and this cancel. So x is equal to 2 into 36, which is 18. So to have 18 moles. This will be the answer for this question. Okay, then I'll go to question number 2. Question number 2 is saying that how many grams of oxygen are required? So it means I'm finding grams, which is mass. So I'll put a mass here. Which means I'll put mass here. I'll say mass because I'm finding mass. Put mass here, okay? So how many grams of oxygen are required to? And they said for how many grams of oxygen. So it means I'll put oxygen here. So oxygen is where it's here. So I'll put 3 like this, okay? Then I compare to what now? So I need to read the question. Are required to react with 0.3 moles of what? Of aluminium. So I need to get aluminium, which is this one. So aluminium here, which is since the number of moles of aluminium is given, so I'll write a moles here. So which means we have more mass to more here. So for what? For aluminium, which is 4L like this. Okay. So from here now, I need to say the mass here, which is the mixture. So the mixture of oxygen, I'll write oxygen like this. Like this. Then I'll say 2 times this 3 times oxygen, the mass number is 16. So I need to multiply now. I need to use a calculator here. I'll multiply, which is 2 times 16 times 3. And the answer I'm getting is 96. So I have 96 here, 96 here. Okay, open calculation is correct. Okay, good, 96 here. Then which means the mixture here is 96 here, which is the mass. Then the number of moles, as I said, we need to get number of moles from the balanced equation, which is what? Which is 4 here. Okay, then the mass of oxygen is x here. Number of moles given in the question is 0.3 moles like this. Then from here, cross multiply. X times 4, it will be 4. X is equal to, so I multiply now 96 on the calculator times 4. The answer is 384 like this. Then over 4 like this. So you say x is equal to, so this number now divide by 4. So I'll get 96. Okay, I've made a mistake here. On multiplication part, I'm supposed to multiply this times this. So 96 times 0.3. The answer I'm getting is 28.8. So here is supposed to be 28.8 like this. Okay. Then now from here now I divide by 4. This and this cancel. So 4 into 28.8. So divide by 4. The answer I'm getting is 7.2. So I have 7.2, which is grams, because I'm finding mass grams like this. Okay, sorry for the mistake here. The main mistake here was why I'm supposed to multiply 96 times 0.3. The answer is supposed to be 28.8. Then now over 4. So when you divide the 28.8 divided by 4, I will get 7.2 grams. Okay, so I'll move to the next question. Question 3 is saying that what mass of magnesium oxide will be produced when 0.5 moles of magnesium burns in oxygen? So which means the product here is magnesium oxide. So I have a magnesium burns in oxygen to produce magnesium oxide, which means the first stage we need to write the equation. So we need to know that the equation will be like this. It will be magnesium plus oxygen. The product is magnesium oxide like this. So we need to make sure that the equation is balanced here. Oxygen of 2, which means we're going to put a 2 here and also a 2 here, so to balance the equation. Okay, like this. We have 2 magnesium here, 2 magnesium, oxygen 2, so it's balanced now here. Then from here now, they're saying that what mass of magnesium. So we're looking for mass. So looking for mass here. So looking for mass. So I'm going to write a mass here. Then what mass of magnesium oxide? So they want the mass of this one, which is magnesium oxide. Then 2. So we need to check now the number of moles given for which element or compound produced when 0.5 moles of magnesium. So which means this 0.5 moles for magnesium, which is the moles here is given. Okay, for who or for what? For magnesium, for magnesium. So like this. Okay, so remember there's a 2 here, so we put a 2 here. Okay, so now and also there's a 2 here, so I'll put a 2 here as well, like this. Okay, then from here now this mass, so and find the mixture for this element. So I'll find the mixture here, which is a 2 MgO. Okay, so magnesium, so this 2 multiplies everything here, so 2 times 16, which is 32. Then we have again 2 times magnesium is 24, which is 48. Then you add now this plus this is 0, this plus this 7 plus 1 8, so to 8 grams. So I'll put 8 here. Then for the number of moles, here is moles, so number of moles is what? Is 2. Don't forget we are doing mass to mole or mole to mass, because here we have a number of moles. So this number of moles represents the what? This number represent number of moles, and here we need to find the mixture, which is same as mass. Then we'll find if magnesium oxide, so put X here. Then here we have 0.5 moles, in fact. Yeah, so cross multiply. So X times 2, it will be 2X here, then is equal to 8 times 0.5, which is which is 40. So get a 40 here over 20 over 2. I mean over 2. This and this cancel. So X is what? 20 grams. So this is how we're supposed to find it. Okay, hope it's very much clear here. Question 3 is saying that how many moles of ammonia can be produced from 8 moles of nitrogen gas? So for us to produce ammonia, which means we need to have a reaction which involves nitrogen like this plus hydrogen like this. This is a reversible reaction to form ammonia, which is like this. Yeah, this is a formula for the equation for formation of ammonia. So nitrogen here we have 2, here we have 1, so we're going to put a 2. You're trying to balance the equation first. Then again 2 nitrogen, 2 nitrogen. Then hydrogen 2 times 3 to be 6. So it means I'll put a 3 here, so that I have a 3 times 2 to be also 6. So it's a balanced equation now. Then from here now I'll read the question again. How many moles of ammonia? So they want the moles for ammonia. So I'll write mass moles here. I mean moles for ammonia, which is 2NH3 like this. Okay, 2. How many moles of ammonia can be produced from 8 moles of what? Nitrogen gas. So 8 moles for nitrogen gas, which is nitrogen gas. So as you can see, we have moles and the number of moles is given, so which means we're using mole to mole. So we have also moles here. Okay, then we put what? Nitrogen gas like this with which is this one. Yeah, so which means we use mole to mole. Yeah, so number of moles here is 2. Number of moles here, there is 1 here, so it's 1. Then number of moles for ammonia is X. Number of moles for this one, which is what? For nitrogen, which is 1, like this. Then from here cross multiply. 1 times X to be X, 2 times 1 it will be 2. 2 moles. So this is how you do it. Okay, so the next one, which is question number 4, is your exercise. I want you to try this one. I want you to try this one. So the question is saying that how many moles of oxygen are needed to burn 1.8 moles of ethanol, like this. So this is a question I want you to try. Thank you very much.